Hey guys, welcome back to my channel and welcome to chapter 11, continuation on Spring course configuration options. In the first chapter, I covered the cross origin annotation option, and in this one, I want to cover the WebMVC configurer bin option. So this option for WebMVC configurer bin is used in WebMVC scenarios. Spring Boot has auto-configured defaults for when you have Spring WebMVC on the path. And we're just going to see how we can add configurations for cross-origin in this case. So I want to go right to the backend code. Um, Yeah, so in this particular option, you have to declare a bin and it should be available in the context when the application is being bootstrapped. So we can declare the bin inside a configuration class or in the Spring application class. And also you should know that this application class is actually a configuration class. It can act as a source of bins. So we're going to declare a bin of type where MVC configurer and call it course filter configuration. Then I'll return new WebMVC configurer. Okay, so based on what we're seeing on the screen, as I'm trying to create this WebMVC configurer, what has happened is that it's actually, I think, an interface, and it has several methods that you can override. So this is the right time for us to talk a little bit about what the WebMVC configurer is. So you see, Spring Boot is designed to work with sensible defaults. It When you spin up a Spring Boot application, it will study the environment of the application itself and do what we call auto configuration to create sensible defaults it thinks are sufficient for the application to run. It will be able to understand what someone is trying to do based on the dependencies on the path or the configurations in the config files. So this is one very important feature of Spring Boot, and this is why it's really very good for building applications from the beginning. However, it's also a feature of Spring Boot that it backs away quickly when the developer starts defining their own configurations, overriding the defaults. So Spring Boot knows when you've defined your own configuration as opposed to when it should use a default, and it backs away pretty quickly. So this WebMVC configurer is simply one of those APIs defined by Spring to enable us developers to have a leg into the configuration, into the auto configuration, and have impact or influence over what is configured and how. So some of the things that we can customize uh, are basically encapsulated into different configurers. Okay, I've mentioned this. So for WebMVC, the WebMVC configurer is the API through which we can customize WebMVC specific things. There are also security configurers. There are different kinds of configurers. But for now, we are covering WebMVC configurer. And what you see on the list here is, on the dialog box here, is a list of what we call callback methods. So when you create the configurer, your Spring Boot exposes to you some callback methods that you can override. And depending on your needs, you can choose which one to override. You can override all of them or just a specific one. And then sort of define your own values if you know what you're doing. And Spring Boot will back away the defaults and use yours. So some of the examples of what can be customized in the Spring MVC ecosystem is just listed on the callback methods here. Because, for example, you can see some common methods like let me see. Yes, handler exception resolvers. When an exception happens inside any of the handlers, like the controller methods, I think you can add some resolvers here to customize that behavior. Then message converters, basically converting between different message formats, JSON, XML, and I think binary and all this. Basically, I'm trying to look for common ones. Ours is here. Add CORS mappings. This one is specifically used to do what cross origin annotation was doing for us in the controllers. Then we have add resource handlers. So basically, well, these are handlers for resources. I think mostly static resources you can add, and based on the path, it will know what to do. By default, I think the WebMVC reads specific resources from specific directories, like the asset directories. But I think you can sort of override that and define some things. It's really beyond the scope of this video. And then there are interceptors. These are like little callback functional interfaces that are added to your request handling flow such that they can be invoked to perform some side effects or to do some checks. So if you know about interceptors, you can actually add them here. And then there's just a host of others. But for our use case, we are going to override the add course mappings because that's what we want to that's what we want to define or customize. So yeah, here it is. And now, so if you study the signature of this add course mapping callback method, you will see that it is past course registry argument. All right. So what is the course registry argument? Simply put, it's a list of course registrations. That is it. Nothing else. We can even look at its code here. You can see this is the defining attribute inside the course registry. It's just a list of course registrations. And what is a course registration? We can even check it out. A course registration is simply a mapping of path pattern to a course configuration, right? So you have your path API slash course, and you define a course configuration using the cross origin annotation. Then during bootstrapping, Spring Boot will read the path and read the cross origin annotation, convert it into a course configuration, and create a course registration for it. So, and we don't need to dive too much into that for now. And then that is what course registry is. So then, how do you define course configurations? We need to remove this default and call what the method called add mapping. Okay, so this method called add mapping, I think it's the only method on the calls registry. Yeah, the rest are, yeah, it's the only method defined in the calls registry. So the add mapping method is used to define path course registration combinations. So you can define any number of course configurations this way. And I think this is really all you need to understand this about the signature of this. The rest is similar to what we were doing with the cross origin annotation. And so what I want to do is to, for us, like we've been doing before in the demo sessions, to run through a couple of test cases. I'll read it first, and then we see the result we expect and run it so that we learn things in like the test-driven development format. And I believe that things stick better that way. So I'm just going to look at the couple of test cases I prepared, and we start off. It's supposed to be semicolon. Okay. So, all right. So we're going to start by playing around with a couple of configurations we saw in the cross-origin annotation section. So here I have added a mapping, but I need to add a path, right? So let me try and target API slash chorus, because we have such a controller here. Okay. So, all right, API slash course, I can define, so you can see we can define a couple of the configurations we already know. For example, allowed origins. I can set it to wildcard. So let me just start this so that we test things as we go, not coding a lot and not testing. So the server has started. Now I want to call that API. And as we did before, let me make this a pre-flighted request by adding a custom header over here. So the request is going to be sent. Yeah, pre-flight request successful, actual request successful. So you can see that everything else is as usual. We are now going to be focusing only on the response headers. Content type is allowed by default. Allowed methods are the ones we talked about. Access control allow origin is a wildcard. Max age is 1,800. So we can also target a specific origin instead of using the wildcard. So I can add here. Okay, let me restart the server. So the only thing we expect to see is that the allow origin will change from a wildcard. So let's refresh that. Options request successful. Allow origin is now localhost 3000. We're seeing the effects of our changes. Okay. So another thing I can do is make this something else. We expect the request to be rejected at that endpoint. Okay, server started successfully. Let me expect a forbidden response. Yeah, here it is. If we look at the Spring logs, we'll see that origin is not allowed. It's been rejected. So we've seen that. So if I go back and I allow this, then let me try and add a couple of other configurations. I added a header over there. So let me try and make it explicit. Remember, if you don't define, then there will be defaults, and the defaults are relaxed for a couple of headers. So allowed headers is one of them. But if I add here x custom header, but I'm passing in content type, the origin will be successful, but no, we know what will happen with this. It's going to be rejected. It's like a repetition, but it's okay. It's still going to be rejected, but I wanted to go one step ahead. So it's rejected, forbidden. So if I add the content type header here, now the server allows X custom header and content type, and we're only sending content type. So it should accept. Yeah, now it has accepted. And if we add another header here called authorization, doesn't matter the value. What will happen is that the pre-flight request will not fail with forbidden because at least one of the headers is allowed. So Spring Boot will just, the options request or pre-flight request will simply return which of the headers is allowed, and the browser will take it up from there, compare with which ones were requested, and write a failure message. It will reject the actual request and write a failure message that such and such an header or some headers. Let's even add a third one, X custom. name. Let's add that. It will say this list of headers are not allowed by the based on the cross origin, based on the pre-flight response. So let me save that. As you can see, pre-flight request has passed. We requested for three headers: authorization, content type, X custom name. But we know that only one header, one of these is supported, and that is content type. So the allow headers is only having content type. And if you look at the error message, it lists for us the headers that are not supported. It has been blocked. Custom header name, custom X custom name is not allowed by access control in pre-flight response. So why didn't it talk about authorization header? Let me refresh that. Okay, I think it's taking on the last one. If we switch the positions of these, maybe it will. Maybe it takes the last one. It's I expected it to show the list, but we shall see on the Spring terminal. We shall see what it says. So, oh, X custom name. It's not talking about the authorization header. Okay, so let's see what the Spring console says. Okay, let me repeat the request. I need to see the rejection. Oh, wait, it's with the options request, it doesn't really reject. So it's only when Spring rejects that it gives the, yeah, that it gives the error message. So basically, I expected to see both, but again, if we solve X custom header by removing it, we shall see that it will reject the authorization header also. So basically, it's applying the rule to headers one by one. I expected it to list out all the headers that are not supported, but it's okay. At least we've seen what we wanted to see. So then we've seen a configuration with the header. I can show you a couple of others. Let's remove the unsupported headers. Okay, we can add another configuration here. Maybe max edge and list it to 3600 seconds. I'll restart it. Remember before it was 1800, which is the default. So now that we've set our own explicit value, if we refresh and I open here, now it's 3600. So I'm sort of just showing you the options available for defining the configuration options for CORS. And it is mostly just the same as using the cross origin annotation, but I just wanted to make sure we clear that out of the way. And then I want to show you something. Basically, I think we mentioned that if we define a single, so let me remove all these mappings, all these configurations. Up to here, I only leave the path. So if we define something like this, basically it's similar to defining the cross origin annotation on the controller or on the method. Remember, we said cross origin annotation sets all the default course configurations. So you can override the defaults by defining specific parameters inside it. So basically, it's the same approach here because the way it is now, everything is going to be allowed apart from the ones that are not allowed, like allow credentials is false by default, and then expose headers is restricted by default, and that. But the rest of the like allow headers, allow methods is all lax when we define the configuration like this. So we can come back here. In fact, I can add all the other headers I had added before. Everything will be okay. Nothing will be rejected. So I just wanted to clear that out of the way. All the headers we've defined are allowed, yet I didn't define them. So that is the default configuration, which is lax by default, similar to cross origin. And so there is another use case I want to talk about. You can actually define any number of mappings you want, right? You can define any number of mappings you want and target different endpoints and have different configurations for those different endpoints. So this is sort of like the similar. This is similar to the example of defining cross-origin annotations on different endpoints. Okay, so you can define different ones targeting different APIs and give them different configurations. So just to draw the similarity with cross-origin annotation, I want to do this. So when I do that, okay, let's update. It will still work either way. Um, Remember, we are not, let me first go back to this. Remember, we are not targeted the second method here. So I want to first show you that this mapping is not going to cover the second API. So I come here. If I change this to CORS 2 and I save, the request is rejected. Reason being, there is no origin header, allow origin header in the request. So I could solve that quickly by adding API CORS 2, and then I refresh. Yes, then I come back here and I start. Now it has gone through because we've added a configuration for the second endpoint. And you could also do this now that I have these. Controllers usually have a similar path route, so I could just mimic that here. Request mapping. I could say these are all requests to slash API should come to this controller. And then in my get mapping here, I remove that API prefix. I remove this one here. So everything will work as it has been working before. This is just a change in semantics. Okay, then I come here, I run that, successful. I go back to course one, successful, no errors. So with this change, what I'm about to do next could make more sense. So I could do that. I'm saying this is a path pattern, remember. So slash API slash anything else that comes after, any other path pattern that comes after is okay. So effectively, I'm targeting everything on this controller. It would be similar to declaring cross origin over here, right? So now this should work for all the endpoints I've defined. So let me remove this. I run that. It is successful. You can see star all the default configs. I could go to two. I save it, trigger pre-flight. It's successful because I'm sort of targeting everything. This is how you can adjust the level of scope, the scope of your configuration. You can apply so many path patterns here. You use the AND style. So if you know more about that, you can really do some powerful manipulations here. So I want to confirm something else. So now that I've shown how you can adjust the scoping, I want to go back to defining different configurations for different endpoints. And it calls two. So basically, I can say this one should allow Allowed origins, HTTP, localhost 3000. Then this one should allow only 4200. So this should fail, that should pass from our React application's origin. Okay, so if I come here, I'm on API CORS 2, I can come to 1, I save. The request passes because our allowed origin is localhost 3000. So if I change this to 2 and I save, the request has failed because the origin is not allowed. If you go to Spring Boot logs, you'll see localhost 3000 origin is not allowed because of this. So you can target different endpoints with different configurations. So let me say that 3000. Now both of them allow the same origin, and I want to add another field. Let's say, let me go back and play with the headers. So I had here content type, X custom name, authorization. Let's say I have here add allowed headers, authorization, then type. So this time it's X custom header that's not recognized. So I want to move this over here. So in the first one, I allow authorization and content type header. In the second one, what should I allow? So let me say I allow authorization and X custom name. No, let me make content type shared one. So one accepts content type and authorization. The other accepts content type and X custom name. They all accept the same origin. So let me refresh that. So which one do you think will fail based on our parameters here? Actually, both will fail because content type is supported, and then custom name, X custom name is supported in the second one. Authorization header is supported in the first one. Okay, we're going to play around with it. I just want to show you the difference. So CORS 2, content type, X custom name. It's going to fail because there is authorization header here, and authorization header is not supported. Yep, it has failed. It requested for authorization, content type, X custom name. It received content type, X custom name. And in the console, authorization is blocked. So the request was blocked. So if we move to CORS, it will fail because it doesn't have X custom name, as you can see from here. It has only authorization. So we shall also see that in action. So we don't even need to look at the pre-flight request, but you can see authorization content type is allowed, authorization content type X custom name requested. So X custom name is rejected. We can see here X custom name. So different rules for different endpoints. Because if you remember that a mapping is simply a mapping of the URL or path pattern to a course configuration, you'll understand the level of granularity you can achieve here. So let me again allow all the headers, content type, custom name, and authorization. Let me add this there, and then I add here authorization. So I'm just going to restart that. Both of the requests must pass now. So, ta-dam. Yep, this request has passed. If we go to course 2, it also passed. So, yep, everything is okay. So, access control max age. Let me first change the value for each of them. Let me change here to max age. I want to change it to 7,200 for course and 86,400. That's like a full day, 24 hours. Course too. So you're just going to see them having different values in the pre-flight response. Come over here. Course 2, 86,400. Over here you can see it. Then course, let me clear that log. 7,200. Pretty clear. So then, so I want to raise another point. In the previous video, we've just been talking about combining of configurations in different scopes, and we looked at the rules of combination. However, there is a common misconception with this web configurer course mapping utility, because as you can see, we are mapping to this to the. We already saw how to map to the whole controller. I mean, someone could say, okay, if this is also a way, if we could map to the whole controller like this slash API, why don't we dry out the common configurations from these two definitions and put them in the controller? Why don't we do that? Why do we keep repeating ourselves? Why don't we apply the dry principle and move these over there? So if someone says that, we can say, all right, let's move the origin so that this one no longer has an origin. Let's move the allowed headers so that this one already has allowed headers. We refactor this code. Maybe you're doing a code review and you're advising someone, please stop repeating things everywhere. Just repeat what is just use what is changing in a separate config, but other similar configs, keep them. There's a way to target the entire controller, just the same way we could define a cross origin annotation here to cover these two configs that will apply to all the endpoints, and then at each level we define a max age. So in this case, we've done something similar, right? So let's just refresh. Let's restart the application. So what do we expect? We expect that the request will work as before. API course 2 will both allow all these custom headers, then it will allow this origin. Okay? But there should be a difference in only the max age returned in each one's pre-flight response. Okay, so I want to prove you wrong on that first before we discuss what I want to discuss. So I start, the request has passed. Okay, slash API slash course. The request has passed. Now um, let us check the configuration here. Max age is 1,800. Max age was supposed to be 7,200. Why is it 1,800? Then we check, maybe there's a problem with course 1, so let's check course 2. It has passed again. Max age is still 1,800. Why is it not 86,400? Okay, think about it. So if you don't know the answer already, all the rules I talked about of combining configurations does not apply within the add course mapping callback of web configurer. Here, what happens is the first path to be matched is what is applied. Okay, the first path to be matched is what is applied, and that's it. Spring Boot will not try to say, okay, how many paths match this? Let me try to match them. No, the first path pattern that matches the request is what is applied. So when I sent a request to API course, it was intercepted by this. When I said to API course 2, it was intercepted by this. That's why all these things are allowed, the allowed headers, even the origin is allowed. But these ones were never detected because when this particular mapping was detected, Spring Boot used the configuration they are in. So if you want to see in a more aggressive manner, you could even set here HTTP localhost 9000. So this should fail if indeed this is the API this is the configuration that is used. All right. I can say here the same. So they should be rejected, but they will not be, as we've already seen that this mapping is going to intercept both requests. So I refresh here. The request is working as expected. Everything is still the same. None of these changes made any difference. Okay. So, having made that point, never try to combine configurations here. Just know that the first path pattern that will match the request is what will be used. To prove that to you, if I move this over to the top, because Spring Boot puts this in a list. You remember, this is a list, and a list is an ordered collection. It starts from 01, index 0123. So whatever is inside the list will be treated in the same order it was received. So Spring Boot will add these mappings, these configurations based on the path. And when a request comes, it checks one by one, which the first one to match, it doesn't continue with the iteration. It just returns that configuration. So I want to show you that now this one will be applied for slash API course requests. It will be rejected because of port 9000. The origin is not matching. So API course, yep, I save. Now the request has failed. Why? If we look at the Spring Boot, localhost 3000 origin is not allowed. So if I come here, I change this to something like wildcard. Okay, before I even restart the server, what about if we call this? This one will not fail because Spring Boot will check this first pattern. It will find that it doesn't match. It will check the second pattern. It will find it matches, and it will not proceed to API slash course 2. It will use this configuration to govern, to apply the course specification to the request. So let's come here and we change this to course 2. We save. Request is successful. Reason being, the configuration that's applied is this one, which is relaxed. It allows all headers. It allows the origin 3000, localhost 3000. Okay. So this is something very important to note because it's easy to assume that you can combine configurations the way I try to do, dry out common configs and then just create mappings for other specific URLs to add the specific configurations. But that is not the case. It will look through first come, first serve. Right. So having made that very clear, however, now the last point I want to make is that, however, if you want to combine configurations, this is what we can do. You would need to apply. You need to create also cross-origin annotations. If you want to target, if you want to override and combine configurations, then you cannot do it all in WebMVC configurer. You need to define a sister annotation inside the configuration, a sister configuration inside the controller using the cross origin annotation. So how do we do that? Now, what did we want to achieve before? Let me first bring back this guy. Let me remove this one. Oh, let me just do what I was planning to do. Let me take this guy up, bring this one down. So the fact that these two APIs were not, these two configurations were not recognized. Let's see what we wanted to do. We wanted to make API course use max edge 7200 and API course 2 use 86,400. We'll leave the configurations here, but I'll show that it's still not working so that you know nothing has changed. API course 2, I run it. The request is successful. What is the max edge? It's 1,800. Then API course 1, sorry, course 1 runs. Where is the pre-flight? Here, the latest, still 1,800. So if I want to apply this override in API course to API course, I can do this. I can add another, I can add configuration here using the well-known cross origin annotation and make it 7,200. And then I also add another here, it 86. So this is what Spring Boot will understand because this is how it can combine the configurations, both the centralized configuration and the localized ones. So now we are going to see a change. API course, we run it. If we check now you can see 7,200. If I change this to target API course 2, I save it. Then here I have 86,400. So from this point on, you can apply the combination rules that I had listed in the what? The combination rules are listed in the previous video when we were tackling cross origin. We've just combined the specific field, in this case max age. You can see it's overridden. However, I just want to show one example. If I wanted this guy to support an extra header, allowed header, this is X custom name. Now I want to do X anything, allowed headers, and I set here X only CORS. So if I set this here, it is not going to override every definition I've set here. Otherwise, if it overrode everything, then our request would fail, as we are going to see. Let's see if the request fails. Remember the rule for combining list-based headers is additive. It simply adds and enhances. So if I try that, request is successful. Let's look at the pre-flight request. It requested for authorization content type X custom name. Authorization content type X custom name. But if we add X course only, which was never there before, and we set it to true, then if I save it, let's see for ourselves. Okay, so I request for the headers authorization content type X course only X custom name. What does it respond? Authorization content type X custom name. So I think I have misspelled something. Okay, X only course. Okay. So let me remove this. Remember the error it had given. Field X course only is not allowed by allow headers. So that error message was correct. So now that I've corrected the typo, okay, let's see why it has failed again. So, all right, let me check here. X only course is not allowed. If I check here, authorization content type X only course. Oh, all along I'm calling API slash course 2. So course 2 does not allow this header, but course allows it. So let me change this. All right. All other corrections we did were right, but we also misspelled the API path. So now the request is successful. You can see all the headers are here, but they were not available for API slash course 2 because I didn't define. And just because I defined this here did not override what I defined centrally here in the MVC configurer. It just added it. It created a bigger array and combined the two settings. So basically, all the other rules of wildcard versus specific, then default versus explicit values is going to apply for this combination. So this is how you can combine types of configuration. You can declare the WebMVC configurer bin, and then also add extra settings, fine-grained settings at the controller and method level. And these will all be combined. Remember, the combination doesn't happen within the MVC configurer. There it is a first come, first serve approach, first in, first out. So in this case, this is how you can combine with the WebMVC configurer settings, and you will get what you want like this, just like we've seen. So I'll stop it there. Join me in the next video when we cover the course filter where Spring Security is involved. So thank you very much for your attention and catch you then.